All right, hello, Reese and who else? Eli and Gabe. Reese and Eli and Gabe. We are starting chapter 5, and there's lots of papers that I'm giving you. So I'm giving you a paper that looks like this, and this is the back of it. And then I'm giving you the notes paper, which looks like this, and it is a stapled page. Woo! And then the homework assignment, which looks like this, okay? 5-1, we are taking 2 days to do, okay? So we'll do half of 5-1 today. It's rather short. 5-2 tomorrow, but if we would put those, 5-1 first half today, 5-1 second half tomorrow, if we have school, unless we have a snow day, right?
We do.
If we would try to do all of 5-1, it would take like almost all periods. So that's why I split it up into 2 days, and it's a little bit better digestible wise. This paper that you have here, this is like your quadrant grid, whatever, that has all 4 triangles on it. 5-1 is only this top one and this top one. This is section 5-1. Don't write that down. But anyway, that's 5-1. Okay, 5-2 is when we will go over centroid and orthocenter. Okay, you don't have to write that down. You don't have to write that down. You don't have to write that down. Okay, but 5-1 is these two. 5-2 is these two. Okay, so technically, this grid will take 4 days to complete. Does that make sense? Because we'll do 2 days of 5-1, 2 days of 5-2. Got it?
Oh my Lord, have mercy.
Oh Lord, have mercy. All right, here we go. So we're going to start by doing some constructions. Draw the best you can and take this really seriously, okay? You have a note card. Here we go. We're going to construct something with this triangle, and this is an acute triangle, that's called the circumcenter. Put it away. Called the circumcenter. All right, here you go. Ready? Here's how you construct a circumcenter. What we want to do is we want to bisect the sides. This is the grid that we are on. We're on the top left corner of the grid. We're going to fill him out first, and then we're going to go to the notes for circumcenter. Okay? We're going to bisect the sides. Okay, what does it mean to bisect?
Perfectly split the angle.
Split in half, okay? But we're bisecting sides, not the angle, right? Okay? So, like, let's say I'm going to bisect this bottom side, right? What I'm going to do is I'm going to eyeball real quick, and I'm going to try to find the center, and I'm going to put a dot on that center. So you do the same. Try to eyeball and find the center of the bottom. Okay, if you want to take your note card and fold it in half to find the center or measure it, you can do that as well. I don't care. To find the center, I'm just going to eyeball, okay? Now, the next thing that we want to do is we want to bisect it, so we want to split it in half using a line segment, okay? Now watch real quick, and then I'll show you what we're going to actually do, okay? If I take like this line segment right here, that technically splits that bottom side into 2 equal pieces, right? Okay? But I don't want to do it that way. I want to make a perpendicular bisector. So what's that going to look like?
Up and down.
Straight up and down, right? Like I want to make him like at a 90-degree angle. Okay, now, if you can't eyeball your 90-degree angle, this is where your note card comes into place. So put the corner of your note card on that dot and use that to help you make a perfect 90-degree angle, right? That's why I gave you a note card. So put the corner of your note card on that dot and make it line it up with the bottom edge and line it up here, and then you'll trace that line right there, okay? That will help you make a perfect 90-degree angle, okay? Good? Questions about that? We want a 90-degree angle. We want a perpendicular bisector, okay? So he like splits him like that, right? He's cutting him in half, that bottom side, right? Okay, now notice this triangle is not an equilateral triangle, so it does kind of make it look like you're lumping off like a small section and a big section. That's because this is not an equilateral triangle. You didn't do it wrong. It's just because it's lopsided on one side, okay? That is a perpendicular bisector. Now, if you need to turn your paper, we're going to do it to all 3 sides. So I'm going to pick on another side. So Billy's already started doing this one. All right, so we're going to do a dot on that segment, make it halfway, and we're going to make it a 90-degree angle. Okay, use your note card if you need to. Here's my 90-degree angle. Okay, got it? Then we're going to do the same thing with the third side. So the third side, I'm going to split it in half, and I'm going to make it a 90-degree angle. Okay, and guess what? All 3 of those lines should come together and meet at the same spot. Ish. Ish. Mine are like not quite exactly the same. But this should all end up meeting at the same spot. Okay?
Okay.
All right, make sure that when you do this, you include your little boxes in the corner so we do know that they are 90-degree angles.
Mine didn't line up at all.
Okay, they didn't line up at all. Then your circle in the middle is just going to be a really big circle. Okay? Just make him like this big to fill in that little hole right there, right?
I think I'm a little left on the bottom.
Okay, then just erase your bottom one and do it again, okay? All right, before we start talking about the circumcenter, that center point right there, okay, let's mark some stuff. So, one more thing that I need to do, like this bottom side, we split them in half. How do I know that we split them in half? What can I put on my diagram so that I know we split them in half?
Do.
Like, let's do a tick mark. Tick and tick, right? Okay? Let's do the same thing for this left side, okay? But I don't want to do tick and tick, right? I want to do 2 ticks. I want to do 2 ticks so that I know that this is the same as this, but it's not the same as the bottom ones, right? Make sense? Okay? And the third side, let's do 3 ticks. 1, 2, 3, and 1, 2, 3. So we know they're the same as each other, but not the same as the other sides. Got it? Mm-hmm. Okay, so those are perpendicular bisectors, all right? Now, couple more things. This dot where they all come together, all 3 of your lines should come together to kind of be in the same position. This is called the... So you're so smart. That's called the circumcenter. Ha! Okay, now I will warn you, I had a geometry student like 3 or 4 years ago go really red in the face because they used the other C word that also starts with circ, and they did not say circumcenter, but it has to do with like other things, okay? That's not the same thing, okay? And it's not circumference either, okay? But they went really red in the face because they said the wrong word, and that's not the wrong word. We might laugh at you just a little bit if you say that word. But anyway, circumcenter. Circumcenter, okay? Anyway, all right, so there you go. That's the circumcenter. Now, the special thing about circumcenter, this is the important part, okay? We bisected the sides, okay? Take note of, like, look on my diagram, like this chunk right here, and this chunk right here, and this chunk right here. Are those all the same distance?
Doesn't look like it.
Doesn't look like it, right? Like this looks shorter, right? Yeah. Okay, but here's what is true about circumcenter. So even though we've bisected all the sides, what will happen is, and this is really fancy, this guy right here, this length, to this dot, this length to this dot, right here, this vertex, and this length to this dot are all the same length, right? It is. I mean, maybe not on my picture. Yeah. So the distance to all of the angles will be the same. So let's name our angles. I'm going to call this angle A, angle B, and angle C. And let's call our circumcenter, let's call that like Z or something. We'll do something crazy weird there. Okay? So even though we have bisected the sides, I'm going to put a star here that says the circumcenter is equal distance to the angles, right? If I draw that dot back to each one of the angles, those distances will be exactly the same, okay? So here's how this works. If I have like a town here and a town here and a town here, and I'm trying to find exactly the middle of them, like Google Maps would do this process and find the exact geographical middle of those 3 places, right?
It does it for you?
What? I don't know. Like if Google Maps was able to do that, they would do some sort of process like this, right? It might be able to. I don't know. Maybe. What? Like how many congruent triangles you mean?
If you look down here, it says congruent parts.
Okay, just wait. We're gonna talk about that. Okay, so the parts that are congruent is like AZ. This chunk right here, AZ, line segment AZ will be congruent to what? BZ, and also congruent to CZ, right? The distance from each of the vertices to that circumcenter Z part, all of those will be the same, okay? So we bisected the sides to make that dot, but then if we map it back to the angles, those distances will always be the same. Got it? Okay? All right. We're going to go through the notes, and we're just going to get through circumcenter today. Tomorrow we'll do incenter, so we'll fill this out, and we'll do that part tomorrow. Okay, so go to your notes. Oh, wait. Go to the back side. Go to the back side of this paper. We'll fill in circumcenter, okay? We'll fill in circumcenter on here. Circumcenter, they have them labeled as, like, different things, okay? So take note that in this diagram under circumcenter, they've done the perpendicular bisector and the perpendicular bisector and the perpendicular bisector. It kind of looks like those 3 segments are the same, but they're not.
They're not?
Like, probably. This one, I don't know. One of them might be shorter.
What if it's an equal lateral?
What if it's an equilateral triangle? Will those distances be the same?
Yeah.
Yes. Yes, good thought, okay? But the thing that is the same is that AM, I'll do it in green. The green segments, AM and BM and CM, those will be the same, right? Those will be the same distances, okay? All right, so it's created by the perpendicular bisectors of the sides. We're bisecting the sides, splitting the sides in half at a 90-degree angle. And that's how we create the circumcenter, perpendicular bisectors of the sides. Okay, important facts. The blank is equidistant from each blank of the triangle.
Angles.
The what?
Equidistant.
The what is equidistant? Equidistant, yeah.
The corners.
The
Equidistant, but.
circumcenter. The circumcenter is equidistant from each what? Vertex or angle, you can put. I'll put both of them. Vertex or angle. Okay. The circumcenter is equidistant from the vertex or each angle of the triangle. Okay. I'm also going to put in here what three pieces are the same distance, like the same length.
AM, BM, and CM.
AM, BM, CM. Okay, those are all the same distance. So if we're looking at lengths, and that will be part of your homework assignment. They will give you the length of one of them, and they'll see if you can figure out which ones are the same, right? Okay, so there's that. All right. Yep, it's not too bad. Okay, bisectors of triangles. Let's go to the notes. So this is the stapled page. These are the notes. Okay, we'll go through all of this until we get to the end of circumcenter, which I think is like just example 2. So we'll stop at example 2, okay? Or after example 2, okay? Here we go. Bisectors of triangles, all right? Take a look at these two diagrams at the top, right here, bisectors of triangles. They have taken segment AB and they have split it in half. How do I know that?
Because of P.
Because of the tick marks, and P lives in the middle. Now, PQ is what's splitting it in half. Is that a bisector?
No.
No.
Is it bisecting? Is it splitting it in half?
Yeah.
It's bisecting, but what is it not?
Per-
It's not a perpendicular bisector, right?
Yeah.
So it is a bisector, but not a perpendicular bisector. Let's look at the next diagram. JK is the one that's getting split in half. Those two little tick marks show me that, but this one is splitting it at a 90-degree angle. So this is a perpendicular bisector versus just a regular bisector. Does that make sense? Okay, you see the difference between the two. Both of them are bisectors. Both of them are splitting them in half, right? But the one is at a 90-degree angle and the other one is not. Got it? Okay, let's go into example. I'm going to skip the box and see if we can just figure this out. Example 1, we have an A, B, and C. And we've got this going on here, okay? Now, out of those little, all those little lines, like A, B, A, C, whatever, all those, which line is the perpendicular bisector?
CA.
CA, this guy is splitting at a 90-degree angle, this guy in half, right? He's splitting that in half. Got it? So CA is the perpendicular bisector. I'm going to say perp bisector is CA. That's the one that's cutting it in half, okay? That's the perpendicular bisector, okay? They want us to find the measure of AB. What the heck?
4.1.
Is it 4.1?
Yes.
I believe so. Because it's splitting it in half and it's creating kind of like the top, the same as the bottom, if the bottom's labeled 4.1, we can assume the top one is also, okay? So 4.1 is the answer to AB. Got it? Like, this is not terribly difficult. All right, WY is what we're looking for this one. Okay, now, here's the deal. This one, we do not know that it is the perpendicular bisector. We know that XY is perpendicular. But do we necessarily know that it is a bisector?
It does not show any tick.
It doesn't show any tick marks. But what it does show is this is 9 and this is 9.
So then we have.
So if this one is 3, does this one have to also be 3?
Yes.
Yes. Okay. Now, somebody said that's an equilateral triangle. It is not. What kind of triangle is? Isosceles. And the reason, like the only reason this works is because it's an isosceles triangle. So this is 9 and this is 9. So WY is 3. Okay. We did not originally know that that was a perpendicular bisector, but we can assume that now because of the 2 9s, right? Okay. So there's that. We knew he was perpendicular, but we didn't know he split him in half. Okay. RT. We do know which one's the perpendicular bisector. SR is bisecting at a perpendicular QT. He's split in half, okay? So they want us to find some stuff. What are we going to do?
Assume it's
Solve for X, okay? How do we solve for X? Set them equal to each other. And like this will be the same as this as long as this is the same as that, right? Okay. So I'm going to say 2x plus 3 is equal to 4x minus 7, okay? I heard Josie say just now, add the 7 and subtract the 2x. So 10 equals 2x and x is 5, yeah?
RT
Okay,
equals 13.
but they want RT, so we're going to plug it back in. 4 times 5 minus 7 is 13. That's what RT is. Got it?
Yay.
Good? Happy with that? Not too bad.
You go up.
Like that? Yeah? Okay, I'll stop. I will. Oh, my thing is in the way. You gotta warn me when that thing's in the way. I can make him go away. Okay. Good? X was 5. Plug it back in. You get 13 for RT. Good? All right, couple more things. So here's the deal. When we did our box, like our grid, when we filled out what circumcenter was, we had an acute triangle that was almost the same as what this one is, right? And they bisected this one, this side, and they bisected this side, and they bisected this side, and we came up with a circumcenter, and it looks like that-ish, right? But what happens if the triangle was an obtuse triangle, right?
Oh.
I would bisect this side, I would bisect this side, I would bisect this side, and guess what? The circumcenter
Outside.
is outside of the triangle.
But it's still the same distance.
But it's still the same. So like this distance right here, and this distance right here, and this distance right here would be the same, right? But it's just that that dot is now outside of the triangle, okay? All right, in a right triangle, where I have a right angle, we bisected this side, we bisected this side, we bisected the third side. Where does the circumcenter live?
Right.
On the edge of the hypotenuse side, right? Because this distance right here will be the same as that one, which makes sense because that's the midpoint, right? And this distance would be the same as well. Does that make sense? Okay? So for a right triangle, the circumcenter is going to be on the hypotenuse side. It's going to be the midpoint of the hypotenuse, right? But in an obtuse triangle, it'll be outside, okay? And then in an acute triangle like what we did, it'll be kind of in the middle, right? So that's how that works. So your circumcenter won't always be in the middle. Don't get confused if that happens, right? It's because it's obtuse or right that it's throwing everything off, okay? All right, let's go to the back side. They're going to have us do one more. We have a stove, which they have labeled S, a sink that they have labeled K because S was already taken, and a refrigerator that they have labeled R. And what they want to do is, this is a kitchen, not my kitchen, but a kitchen, where we have a stove, a sink, and a refrigerator, and we're trying to find an island. Do you know what an island is?
Yeah.
Like the little, like sometimes it's on rollers or whatever, but it's like a kind of a table-ish that sets kind of in the middle of your kitchen, okay, that you like put stuff on, whatever, okay? We're trying to figure out where that should go so that it is exactly the same distance between all of those, which means if I want the same distance from the vertices, I'm going to do the circumcenter, right? So I'm not going to touch the vertices, I'm going to do the sides. So get your note card out. I'm going to split this side in half, right? And I'm going to do the perpendicular bisector. So I'm going to make him a 90-degree angle. Okay. Separate each one of the sides and make a 90-degree angle. And find where they intersect each other. And we're going to see if that's the middle.
Dang, that was pretty dang close.
Pretty dang close. Now you know that it's supposed to intersect, so you're like kind of rigging it to make sure it does, right?
I didn't
Ish.
read that one.
Okay.
I didn't.
So this is where your island's going to go.
Mine might be a little off to the left a little
Yeah, it's
bit.
okay. Off to the left. It kind of looks like, as far as the triangle goes, that it is on the left side of the triangle. Like, it does kind of look like it's not dead in the center of the triangle. But that's the way that it works, right? We just said that it won't be in the center, because if it's an obtuse triangle, it won't even be inside the triangle. Your circumcenter is not necessarily in the dead center of your triangle, right? So that's how that works. Got it? So he will be the same distance from K, from R, and from S. That's your island. Will live there. Okay? Good? Happy with that? Okay, your homework assignment, we're going to stop notes there. We're done for the day. But your homework assignment is we're going to do all of them eventually. Okay, so after tomorrow or whatever day we come back, if we have a snow day tomorrow, we will do all of these problems. But the ones that involve circumcenter on practice side, if you're on practice side, are 1, 2, 3, and 7 and 8. Okay, so don't cross off the other ones. We'll do those tomorrow. But 1, 2, 3, and 7 and 8, those are what involve circumcenter. Got it? The other ones are going to be in center, which is what we're going to learn tomorrow. Okay? On the back side is 1, 2, 3, and 7, 8, 9. Those are all circumcenter. Okay?
1, 2, 3.
On skills practice is 1, 2, 3, 7, 8, 9. Now, there is a typo on skills practice. I'll make sure and say this tomorrow because this has to do with tomorrow's homework problem. But the very last one on skills practice, number 12, should say QPA. If you want to fix that now, it should say QPA instead of QPK because QPK isn't even a straight line. QPA is. So I'll make sure and say that again tomorrow, but that is a typo. Okay?
Okay.
Got it?
Yep.
So I don't know how many problems that is, like, I don't know, 11 problems, but they're really short. Okay? So there you go. That's homework for tomorrow, and then we'll add to that the rest of them. Okay? Good? Questions? Not too bad, right? Here we go. Goodbye, people in the video. Where did my thing go?